Hey, what's up? This is Scott again. Recently I was asked to solve a couple of expected value equations for somebody that was in Romania. Just want to make a quick video and show you how they're done. Here's the second question that he'd asked that was written out. A fair die is rolled. Here, find the average number of dots and the variance, right? So this average number of dots, this is telling us that we're looking for an expected value right here, right? And then variance, we'll get to that in a little bit. But to find the expected value of dots, right? So this is going to be a discrete case because there's a finite number of, or a countable number of possibilities for this one, right? So we know on a die we have, right? We have 1, 2, all the way up to 6, right? So what we're going to do is we're going to find the expected value of that. Now, when we're looking at a discrete case, we want to pay attention to this equation, right? Expected value of x is equal to the sum such that I is equal to 1 to n of the probability of x sub I, right? So this is the probability that we're going to get x for each one. Now, there's 6 sides to a die, so our probability here, our probability of any value is going to be 1/6, right? So we can start to fill that into this equation. So our expected value is going to equal to 1/6 times the sum from I is equal to 1 to 6, because we're looking at 6 sides, right? And this, so I'm just pulling this probability portion out of x sub I. Now there's, you can go through and you can add that up, 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? That's a very easy way to do it. Or you can look at, there's an equation where you can find the sum of the first n numbers, right? So sum of first n numbers, we can use the equation n plus 1 over 2, right? And in this case, since we're solving from 1 to 6, are such that n is equal to 6, right? So we're going to have 6 times 7, right? 6 plus 1 is 7 over 2, which is just going to equal, this is 42 divided by 1 is going to be 21, right? So our sum from 1 to 6, our expected value is going to be 1/6 times 21. Our expected value is going to be 21 over 6, which if you do the math, that's going to equal 3.5. So that's how you find the expected value in that case. To find the variance, it's going to be a little bit different, right? I think there's a formula, but we can take a look at what's called the variance computing formula, right? So we're going to have this one here. The variance of x is equal to the expected value of x squared minus the expected value of x squared. Two different terms, right? So this is our expected value of x, and we're going to keep this right here, right? So we know that this is going to be the expected value of x squared minus 21/6 squared. Now we just got to find the expected value of x squared. We can do the same as we did over here. So we're going to have the expected value of x squared is equal to the sum I is equal to 1 to n p sub I of x squared of I. Right? And again, we're going to be the same 1/6, right? And that same, we're going to pull that out, 1/6, sum from 1 to 6 of x sub I squared. Now you go through and you can sum this up and then times it by 1/6, you know, so you would do 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and you can add all those together, or you can use the, there's an equation that you can use for the sum of the first n squared, sum of first n squared. That equation is n times n plus 1 times, I think it's, what is it, 2n plus 1? all of that is going to be divided by 6, right? And in this case, n such that n is going to be equal to 6. So we're going to have 6, and I'm going to leave this out for a reason. N plus 1, so 6 plus 1 is 7. 2 times 6 is 12, plus 1 is 13. And we're going to divide that by 6, right? So these 6 will cancel out. You're going to have 70 plus 21 is 91, right? So we can, this is going to equal to your x, right? It's going to equal to x squared, but we got to divide that by 6, right? Because we got to, oops. So 91 is the first, 91 is your first 6 numbers squared, summed, right? So if we were to look at this, we're going to have the probability of x, the expected value of x squared is going to equal 1/6 times 91, which is equal to 91 over 6. So your variance of x is going to equal, we'll take this, solve it into here, 91/6 minus 21/6 squared. I don't have my calculator in front of me. I can do it real quick for you. We could solve that out. What was that? 91 divided by 6 minus 21 divided by 6 squared. That's going to equal 35/12. So that's how you go about finding the expected value and the variance for rolling a fair die, right? Again, I hope that this has been of a help to you. A couple quick things to remember, right? We're looking at, based on our support, which is going to be 1, 2, 3, 4, 5, and 6, we have a discrete case, right? Because we have a countable or a finite number of possibilities for our problem. And then when we look at our expected value, we're looking at sums because it's the discrete case. The sum of the probability of x sub I times x sub I, right? We can just sum that out, and that's how we would end up finding the expected value here, right? Then we got this variance computing formula. This is something that makes life very easy when it comes to determining variances for different equations, right? So the variance computing formula is the expected value of x squared minus the expected value of x squared, right? Two different things that we're looking at. We've already found the expected value of x right here, which is 21/6. So we can just put that in and get 21/6 squared. Find the expected value of x squared. It's just the same thing that we did when we found the expected value in the discrete case. Plug that all in, and there's our answer. If you've got any questions, don't hesitate to shoot me a quick email with a picture of your equation and your problem. I'll do my best to solve it and do a video for you, so that way you can have a little bit better of an understanding on how to solve your problems.